Good morning. All right, so this week we're going to do a review of everything we've been learning since we've been on quarantine. So here we go. We're going to learn one thing new today, and then I'm going to go over a couple different examples to make sure you guys are understanding this stuff. First things first, you have not heard this word yet, but you've been working with it in the past. It's called discriminant, and that'll be asked of you in some of your work. The discriminant is the part that is underneath the square root. The part that is underneath the square root of the quadratic formula. So all we care about for the discriminant is this part right here, b squared minus 4ac. What this means is when b squared minus 4ac equals 0, then there is only one real solution. If b squared minus 4ac is greater than 0, what's under the square root, that means we're going to have two real solutions. We don't know what they are necessarily, but we know that there's going to be two real positive solutions. And then if b squared minus 4ac is less than 0, then that means we're going to have two imaginary solutions because there's going to be a negative under the radical, and there's no such true number in our number system that will allow for that. So we call those two imaginary solutions. So for example, right here, I did just some math. If I got this quadratic 2x squared minus 3x minus 2, I'm looking at, again, just this part, and I do the math right here. So this is 9, negative 4 times 2 is negative 8, negative 8 times negative 2 is positive 16. So my answer is 25 for my discriminant, which tells me I'm going to have two real solutions. My second example, like this one here, 3x squared plus 2x plus 4, again, just b squared, 2 squared minus 4 times 3, negative 12 times 4 is negative 48. So this is negative 44, so I'm going to have two imaginary solutions. Now, I'll be right back in a second with some math examples. Okay, so here we go. Solve by factoring. We're going to do a couple examples like this, and then also solve by taking the square root. We have not done a lot of this, so it's okay if you're a little confused, and hopefully it can make sense to you in these two examples. If not, again, come see me this afternoon. We'll work it out. Remember, when this is 1 and the coefficient is 1 of the x squared, just look and ask yourself, what multiplies to positive 15? It also adds to negative 8. So I got x minus 5 and x minus 3. Very simple. So now this is the true factor of this quadratic. So our solutions are x equals 5 and x equals 3. Over here, a little more different because my coefficient is now 3. It's not 1. So, but it's nice that it's prime. So if I'm factoring this, it looks like this. Now, the hard part is you got to know where to put the plus and the minus, and I don't know, but this is why you write in pencil. Abel, wait 1 second. So again, because I don't know which one goes where, but I know one has to be positive, one has to be negative because I have a negative. So now let's see here. If I'm going to put this, I'm going to put the 3 here, I'm thinking, and the 2 here. Let's double check. That's 3x squared, 9 minus 2 is positive 7. Oops, all right, so I see what I did wrong. So I got to change this to a plus and this to a minus. Now I got negative 9 plus 2 is negative 7, and this is negative 6. Boom. Now we got our x equals 3. Where are you going? You going out there? Here. Say bye.
Bye.
All right. So now here, make sure when you're looking at this, this is equal to 0. And you can probably do this in your head, but if you want to write it out, be my guest, you got to make sure that we always set it equal to 0, but that's why these ones are easy. 3x equals 2, so x equals negative 2/3 because you would divide both sides by 3. So there are your two solutions. Now, going on down here, taking the square root. This one's actually a lot easier, right, than doing all this intricate work. You just simply add 2 to both sides, and then I got x squared equals 40. I take the square root, plus or minus. Now be careful here because I want you guys to remember everything we did in the previous unit about radicals and all this stuff. 40 has a 4 and a 10 embedded within it, and I always got to factor out all my perfect squares. So now this is going to be x equals plus or minus 4 comes outside as a 2 square root 10. Okay, and there is the answer, taking square root. It's very simple. Over here, let's do this one now. A little more work involved. Plus 8 I got 3 times x plus 2 squared equals 13. We all see that? I think so. Now, divide both sides by 3. Okay? So I have x plus 2 squared equals, and then again, we're taking the square root of both sides. Now, I'm going to do a little work off to the side here because I have a fraction, and if you remember, our rules with radicals, we cannot have a square root in the denominator. So this looks like this. All right, this looks like this right here. Square root of 13 over square root of 3. So in order to get the radical out, stop it. In order to get the radical out of the denominator, I simply just multiply it out on top and bottom, okay? And then I'm left with a square root of 39 over 3. So I have x plus 2 equals plus or minus square root of 39 over 3. And then I just simply subtract 2 from both sides. So then I'm left with x equals negative 2 plus or minus square root of 39 over 3. And that is how you would express that answer. Back to one more example. Okay, so the last examples. I'm going to solve these by completing the square. Now make sure that you're doing this a little differently than if we were finding the vertex, and you'll see what I mean by that. I'm going to get my c to my right side because we are solving, we are not looking for the vertex. So this now factors down into x squared minus 10x. Half of this is negative 5 squared is 25 equals 6. Now remember, I brought a 25 in to the equation that wasn't here originally, and instead of taking it out by doing minus because that'd be on the same side, this is like a scale or a balance. I got to keep it balanced. I bring 25 here, I must bring 25 on this side as well. So now I got x minus 5 squared equals 31. Now we're just solving by taking square roots like we just did a second ago. So now this is x minus 5 equals plus or minus square root of 31. I'm going to add 5 to both sides, so x equals 5 plus or minus square root of 31. That's how you solve by completing the square for something like that. It's just a little more difficult, not by much, but we'll see what we do. I'm just bringing the c to the right side. I'm going to factor out my first two terms. You remember? So now this is x squared plus 4x. Over here I got equals to 14. Half of this is 2, squared is plus 4. Now, I don't put plus 4 here because I didn't bring a 4 into this problem. I brought a 2 times a 4. I brought an 8 into this problem, so I must bring 8 on this side as well. So now this says 2 times x plus 2 squared equals 22. And I'm hoping this is looking pretty easy now. So now we just solve by doing the square roots. X plus 2 squared equals 11. Square root both sides. X plus 2 equals plus or minus square root 11. Subtract 2. X equals negative 2 plus or minus radical 11. Hopefully this is easy for you. I think it should be, but if it's not, that's okay. I will be available at 1 o'clock, and I'll talk to you guys then.